Hey guys, I'm Mukan D'Souza and welcome back to my YouTube channel, Mukamatics. So today I'll be doing some theorems. Theorem 1. A simple graph with at least 2 vertices has at least 2 vertices of same degree. The proof goes as follows. Let G be a simple graph with n greater than or equal to 2 vertices. Let V be any vertex in G. The degree G of V is less than or equal to n minus 1, as V can be adjacent to remaining n minus 1 vertices in G. As you can see in this figure, if there are n vertices, the maximum degree of a vertex can be n minus 1, as it is adjacent to one less, as you can't count itself. So the proof goes by contradiction. Now suppose that no two vertices have the same degree, that is, all the vertices of G are of different degrees. Since there are n vertices and degree of each vertex is less than or equal to n minus 1, the degrees 0, 1, 2 up till n minus 1 is the only way of assigning n vertices. Let U be the vertex with degree 0, that is, U is an isolated point. Let W be the vertex with degree n minus 1, and W has n minus 1 adjacent vertices. This is by the definition of degree. But since U is an isolated vertex, W cannot be adjacent to U. Therefore, W can be adjacent to remaining n minus 1, that is n minus 2 vertices. Therefore, degree of W equal to n minus 1 is not possible. This is a contradiction. Therefore, our assumption that vertices are of different degree is wrong. Therefore, at least 2 vertices have the same degree. Theorem 2 is a handshaking theorem. It's a very important theorem in graph theory. If G, V, E is an undirected graph with E number of edges, then it states that summation V belong to V, degree G of V equal to 2E. That is, sum of the degree of vertices in an undirected graph is twice the number of edges, hence it is even. The proof goes as follows. Since every edge is incident with exactly 2 vertices, each edge gets counted twice, one at each end as degree of vertices. Thus the sum of degree equal to twice the number of edges. This is because if you consider any edge, each edge contributes 2 to the total degree, 1 to one vertex and 1 to the other vertex. Hence, if you consider any graph, the sum of the degrees will be twice the number of edges. This is an example. There are 3 vertices and 3 edges. Each vertex has degree 2. Hence, the sum of the degrees is 2 plus 2 plus 2, which is 6, which is same as 2 into 3, which is 2 into the number of edges. Corollary. In an undirected graph, the total number of odd vertices is even. Let G, V, E be an undirected graph. Let A be the set of even vertices and B be the set of odd vertices. We know that the sum of the degrees of all the vertices will be sum of the degrees of the odd vertices and sum of the degrees of the even vertices. We also know by handshaking theorem that this term, sum of all the degrees of the vertices, is nothing but twice the number of edges. Hence this term becomes 2e. So by rearrangement, we find that the sum of the degrees of odd vertices is 2e minus sum of the degrees of all the vertices. 2 times the number is even, and sum of even numbers is also an even number, and the difference of even numbers is even. Note, if the sum of odd numbers is even, then the total number of odd numbers is even. So if we have this example, this has an odd number which is 1 odd number, so the sum is also odd. Sum of even number of odd numbers is even. Sum of odd number of odd numbers is also odd. So since we have the sum of the degrees, the sum of odd numbers to be even, we know that B contains even number of vertices. Theorem 3. This is similar to the handshaking theorem except that this is for a directed graph. If G of V, E is a directed graph with E edges, then sum of the out degree is equal to sum of the in degrees, which is equal to the number of edges. So this is a graph. Let E equal to A, B. Every directed edge contributes 1 to the in degree of B here and 1 to the out degree of A. Also, a loop at B contributes 1 to the in degree, that is here, and 1 to the out degree here. Hence, the sum of the in degrees is equal to the sum of the out degrees, which is same as the number of edges in graph G. Show that the maximum number of edges in a simple graph with n vertices is n into n minus 1 by 2. Let G be a simple graph with n vertices. Each vertex V in G can have at most n minus 1 degrees. That is, degree G of V is less than or equal to n minus 1 for each vertex V in G. Same as in theorem 1. Let E be the number of edges in G. Now by handshaking theorem, 2E equal to sum of the degrees of the vertices in G, degree G of V. Sorry, this is V. Which is equal to the degree of the first vertex plus degree of the second vertex till the degree of the nth vertex. From here, each degree is less than or equal to n minus 1. So the sum is less than or equal to n minus 1 plus n minus 1 n times, as there are n vertices, which is equal to n into n minus 1. So this is 2E. So E will be less than or equal to half of n into n minus 1. Therefore, the maximum number of edges in G is n into n minus 1 by 2. Note that this is same as NC2. Take this example. Sorry, I could not see the last line. This example, since an edge is nothing but a pair, it can be considered as a combination of two vertices. And since there are n vertices to be arranged in two ways, that is to create an edge, therefore the maximum number is NC2.